anatomy students, welcome to the video series on the integumentary system. Today is going to be video lesson 2, and it is going to cover the epidermis. So let's go ahead and get started. All right, so video 2 in the lecture series, we're going to talk about the epidermis. And remember, the epidermis is going to be the layer of skin that sits on top of or upon the dermis, and that the prefix epi means upon. The epidermis is composed of keratinized, stratified squamous epithelium. So keratinized means that the cells are packed full of keratin. And this is ultimately what causes the death of those cells. The very outer layers of your epidermis, those cells are dead. And that is why it doesn't hurt when we lose them. And we do lose thousands of them a day. They will contain 4 major types of cells. They are keratinocytes. Keratinocytes are, again, we see anytime we see the word cyte, that means cells. So these are the cells that produce keratin. Keratin is the waterproofing agent of our skin. Keeps us, not only does it keep water out, but more importantly, it helps keep water in so we don't lose it to the environment and dehydrate quickly. The other type of cells are melanocytes. They are cells that produce melanin. Melanin is Mother Nature's sunblock. It is what is used to block the UV radiation that comes from the sun. Then we have Langerhans cells. The Langerhans cells will aid your skin in fighting disease, keeping infection out. And then we have Merkel cells, and those are one of the touch or feeling receptors in your skin. So let's talk a little bit about those individual cells. Again, the keratinocytes make up about 90% of the cells. They produce keratin, a tough fibrous protein that provides protection. It helps the cells become that physical barrier that we need to keep infection out. But it also is, as I said earlier, the waterproofing agent in our skin. And your hair and nails are made of densely packed cells of keratin. They are almost all are entirely keratin. Next, we have the melanocytes. Melanocytes produce the pigment melanin that protects against damage by ultraviolet radiation, UV radiation from the sun. When you are exposed to UV radiation, you will tan. That's why many of you go to the tanning bed. You bombard your skin with UV radiation. Your body doesn't like it, so it ups the melanin production to block the UV radiation to keep your cells from burning and or mutating. And that is why people that hail from very sunny parts of the world have darker skin. That blocks the UV radiation. People that come from less sunny, very cloudy, dreary, and rainy places of the world have paler skin. Next, we move on to the Langerhans cells. They are a macrophage that originated in red bone marrow. They are involved in the immune response, so they are the second line of defense that your skin has to fight infection. The skin itself is a barrier, a physical wall to help keep infection out. And then if something does happen to find its way in, the Langerhans cells are there to help rid your body of that infection. And then Merkel cells function in the sensation of touch, along with other adjacent tactile discs or touch receptors. The epidermis is composed of 4 layers of thin skin and 5 layers in thick skin. So when we look at the cube O skin that I will give you, it will have all 5 layers of that skin. But one of the, and I'll mention this again, but one of the characteristics of that skin that has the 5 layers is that skin has no hair. So we find this thick skin that has the 5 layers of epidermis typically on the palms of your hands and the soles of your feet. And of course, there are no active hair follicles on the palms of our hands or the soles of our feet. And that is because of that extra layer of epidermis. All of the other places have the 4, and most of those places will have active hair follicles. But when we go to the skin cube, this will technically be anatomically incorrect, this diagram, because it will have hair follicles and the epidermis will have all 5 layers, which is anatomically incorrect. But every diagram does that so that you see the skin with everything that it could possibly have. So the very bottom layer of your epidermis, this is going to be where active cell division takes place. This is the layer of skin that touches the dermis. This is called the stratum bacilli or the stratum germinativum, because these cells germinate or divide down there. That's where that term comes from. This is always the bottom or the deepest layer. This is where cell division takes place, and it happens all the time. Since you are always losing skin cells, they clearly always need to be replaced. So there is constant cell division going on in the stratum bacilli layer of your epidermis. The stratum spinosum layer is a layer of 8 to 10 keratinocytes. This is where the cells are going to start to be packed full of keratin. The keratinocytes produce the keratin and begin to push that product into those cells. And when they push the keratin in, it starts to push the other parts of the cell out. And this is where those cells begin to lose their lives, basically, is where they start to die. The non-dividing cells of the 3rd layer are the stratum granulosum, and they are filled with granules of keratin. And so this is where, so we've moved from stratum spinosum up to stratum granulosum, and this is where those cells have now started to really start to get packed full of keratin. The stratum lucidum is the 4th layer, but this is the optional. This is the layer that we only find in the very thick parts of your skin, the palms of the hands and the soles of the feet. This is only present in that thick skin. As it says, the skin of the fingertips, the palms, and the soles. So they want to make sure you know that the underside of your finger, that surface, also, I kind of included in the palms of the hand, but they wanted to make sure you knew that there was no hair follicles growing on your fingertips. And then the outermost layer, the stratum corneum, is always the outermost, composed of approximately 20 layers of flat remnants that are basically bags of turtle wax, meaning they are just packed full of keratin and nothing else. And these cells are dead. They're far away from the nutrient layer. They don't have any blood supply. They don't have a nutrient supply, and they're packed full of keratin. And this is why those cells are considered to be dead and why we lose thousands of them to our environment. A snake will shed its outermost layer of skin in all one piece. We lose and shed our skin just a few cells at a time. That's the big difference. So they are dead keratinocytes with no cellular organelles, filled with only keratin protein. So that's all they have. They're just cell membrane full of keratin. They are continuously shed and replaced by cells from the deeper strata or layers. Keratinization is the process of replacing viable cells in the stratum bacilli with more and more of the waxy keratin protein as cells move from the deepest layer to the surface layer. So as they move away from the stratum bacilli, they go through the process of keratinization, which is packing them full of keratin. Constant friction can stimulate the process and produce a callus, even thicker buildup of keratinocytes in the stratum corneum. So if you work with your hands or if you lift a lot, you'll develop calluses on the base on your palm of your hand at the base of your fingers. If you are a runner, or just walk a lot, you'll notice that you'll get calluses on the soles of your feet. And this is due to increased friction. Your body is just trying to make your skin thicker to protect the underlying tissue. Dandruff is an excess of keratinized cells shed from the scalp. So here is a picture and the artistic rendition of all the layers of the epidermis. And we can see the bottom part, we go from deep all the way out to most superficial. So here is the outermost layer. This is the stratum corneum. This is obviously going to be a layer that is either from the palm of the hand or the soles of the feet, because it contains stratum lucidum, which is this layer here. Underneath that, we go stratum granulosum, which is that layer beneath the stratum, and this is where they're really starting to become keratinized. Underneath that, we have stratum spinosum, which is going to be about this deep. And then our very bottom layer right here is the stratum bacilli. And we can see that over here. We go stratum bacilli in the actual microscopic picture. Stratum spinosum is going to run from here to here. Stratum granulosum is going to be this layer. And then stratum lucidum is this paler layer right there. And then your outermost layer is stratum corneum. Types of skin: thin, quote unquote, hairy skin, because it contains the hair follicles, covers all body regions except the palms, the palmar surfaces of your digits, the underside of your fingers and toes, and the soles of your feet. Thick, hairless skin covers those areas that we just mentioned where you don't have the thin, hairy skin. We see it in the palms, the palmar surfaces of the digits, and the soles. Again, those are high friction areas, so we have that extra layer of epidermis to protect the underlying tissue. Skin pigments, what gives us our color. The main pigment player in our skin is melanin. It is produced by melanocytes. Again, cells. Anytime we see cytes, that means cells. So these cells produce melanin, and they are found in the stratum bacilli. So we tan from the bottom layer of our epidermis out. They produce two kinds of melanin: the eumelanin, which is the brown to black color of melanin, and then the pheomelanin, which is the yellow or red kind of melanin. Freckles are clusters of concentrated melanin triggered by exposure to sunlight. Having more freckles is a genetic trait. Now, one interesting thing about our melanocytes, no matter who you are and where your family tree comes from, we all, as human beings, have roughly the same number of melanocytes in our skin. All of us. From the fairest skin person hailing from Ireland, your classic redhead with very pale skin, they will have roughly the same number of melanocytes per square inch as someone who hails from Botswana. There is no difference. They don't have more melanocytes. It's just that the darker you are, the more melanin those cells produce. Some various skin pigments: a nevy or a birthmark or a mole, sometimes called the same thing, are chronic lesions of the skin. they are by definition benign, which means they're non-cancerous. They are not going to spread. They are just there. Malignant melanoma is a cancer of the melanocyte, and of the three kinds of skin cancers, you have basal cell carcinoma, squamosal cell carcinoma. So that's going to be in your outer layer. Your basal cell carcinoma is going to be down in the stratum bacilli of your epidermis. And then malignant melanoma is of the melanocytes. And you can see it has kind of a strange, usually has an uneven shape. There's a rule, they call it the ABCs of skin cancer, of melanoma. If the A is asymmetrical, so it doesn't have a symmetrical shape, it's not perfectly round, or as you can see, this one has a funny shape. B is for borders. If the borders are uneven, you can see there's a dip down in there. C is color, if it changes color. And then D is diameter. And I believe the magic number is somewhere around 6 millimeters. So if you have a lesion on your skin that is bigger than 6 millimeters across, you probably need to have that looked at. I believe it. Don't quote me on that. Remember, I'm no dermatologist. I'm just a simple anatomy teacher trying to make his way in the world. But I'm pretty sure 6 millimeters is considered large enough to have looked at. Some other conditions, vitiligo is a skin condition that causes depigmentation in patches of the skin. The precise pathogenesis or cause is unknown, but it is very, very likely and is mostly believed to be an autoimmune deficiency, which basically means the immune system attacks the melanocytes and causes them to stop producing melanin, which melanin is what makes us darker, is what tans us. And if that section of skin stops producing melanin, it will obviously become very pale. And that is vitiligo. Albinism is a congenital disorder characterized by the complete or partial absence of pigment of the skin. So vitiligo is patches of the skin don't produce melanin and is an autoimmune deficiency. Albinism is genetic and you produce no pigment at all. They're an albino and basically any vertebrate can be an albino. If you've ever been to the pet store and you've seen the little white mice with the red eyes and the pink nose, it's an albino. An albino snake will be white and yellowish and still have the same kind of pattern that a normal colored snake will have, but it has pink eyes as well. It produces no pigment, so it has that white and yellowish, very pale color. It can be seen in just about, like as I said, any vertebrate, including human beings. And a human albino will have very white, pale skin and white, almost kind of a very light blonde hair color because they produce very little or no pigmentation at all anywhere on their skin. Now, with people, we have a different little combination of genes. For our eye color, it's a polygenic trait, which means there are multiple genes that can affect our eye color. So an albino human may not have the pink eye color, but their skin will definitely be very, very pale, which is risky for them to be out in the sun because, of course, the sun can burn them very easily with no melanin production. And another one that we talk about a lot in class, it's technically not here on the notes, is alopecia, since the hair is part of the skin. That is also an autoimmune deficiency where that individual's immune system attacks their hair follicles and they don't have any hair. And in some people, it's patchy. so that part of their scalp or part of their body won't have any hair, but other parts will. And in some people, it is totally 100% all of their skin will produce no hair. So no leg hair, no armpit hair, no eyebrows, no eyelashes. They are their body has attacked their hair follicles and they produce no hair growth. All right, that's going to wrap up the lecture material on the epidermis. All right, that's going to be it for lesson 2. Hopefully that covers everything that you ever wanted to know about the epidermis. If you are on home quarantine, hopefully this has been a big help. So as always, thanks for watching, and I'll talk to you later.